Hello, today we're going to learn how to add and subtract, multiply and divide using significant figures. The first rule we're going to talk about is rule for adding and subtracting. The limiting term is the one with the smallest number of decimals. Now if we're going to add these three numbers, which one has the smallest number of decimals? Well, this number has two numbers to the right of the decimal. This one has only one. And this one has 3. So, what is a limiting term? What's going to limit our answer? Well, the one with the smallest number of decimals, the middle one. Because the middle number 18.0 has only one number to the right of the decimal, our answer can only have one number to the right of the decimal. Now this is a beautiful answer, but in a way it's a lie. We can't represent the 2 and the 3 with any certainty. Why? Well, think about it this way. What is 3 plus an unknown measurement plus another unknown measurement? We simply don't know, so you can't record the 3. The 2. What's 1 plus an unknown number plus a 1? Well, it's not 2. Because this number, 18.0, has only one number that has any significance, any meaning, our answer can only have one number to the right of the decimal. That's the rule for adding and subtracting. Now the rule for multiplying and dividing. The number of significant figures in the answer should be no larger than the measurement with the fewest number of sig figs. So if we look here, we're going to take these two numbers and multiply them. This number has 2 sig figs. This number actually has 4 sig figs. So how many can our answer have? Well, it's the one with the fewest. I highlighted it here. Since I only have 2 numbers that have meaning, in my answer I can only have 2 numbers with meaning. Now, you might say 240 has 3 numbers, but it doesn't. That 0 is not significant. There's no decimal. Remember, trailing zeros are only significant if there's a decimal written. So that number only has 2 significant figures. Now it's not 24, it's 240. You need the 0 to show dimension, but it's not significant. It's not a number that we can rely on. What is 244.068 rounded to 2 significant figures? It's 240. Now, you're going to need some more practice. Let's say I want to find the density of this object here, this like rock object in this graduated cylinder. How would I find it? Well, we'd first weigh it and find out its mass. And then we would take its mass and we would divide it by its volume. How would we find its volume? Well, here we're finding its volume by water displacement. We have 20 milliliters of water in this graduated cylinder. We drop the rock-like object in there, and it goes up to 23.21. And so when you subtract 23.21 from 20, you get 3.21. That's its volume by water displacement. Now, how do we represent the answer? Well, we divide the two and we get this humongous number. This number that is a lie. It's a number your calculator tells you, but it's not a number that we can write down, that we can actually tell somebody that we know. We can only have an answer with 3 significant figures because this measurement only has 3 numbers, so our answer can only have 3 numbers. That's the rule for multiplication and division. Our answer can't have any more significant figures than the measurement with the fewest number of significant figures. Our answer has 3 sig figs because this measurement has 3. Now, why not write the whole thing again? Well, this makes it look to a scientist like we know the density to the 10th, 100,000th, 10,000th, 100,000th, millionth, to the 10 millionth. We certainly did not do a good enough measurement here to find out an answer to the 10 millionth. We can only show an answer that's as accurate as the measurements we used to get that answer. One more example. We're going to go back to the rules for adding and subtracting. We want to find the perimeter of this box. Well, to find the perimeter, as most of you know, you add the 4 sides. And there we have the 4 sides written and added all for us. Well, because we're interested in adding, we need to know how many numbers are to the right of the decimal. We have 1, we have 1, we have 2, and we have 2. So how many numbers to the right of the decimal can we have in our answer? Well, the answer is 1, because both of these numbers have 1 to the right of the decimal. What is this number with only one number to the right of the decimal? Well, here it is, 294.9. Why 0.9? We use the 0.6 to round the 0.8 to 0.9, and there we have our answer. So we've just talked about the rules for adding and subtracting, multiplying and dividing using significant figures.